There we go. All right. So they have here on this page, they've got steps for you. If you are a steps person, there are steps right here. These are the exact steps to do in the right order. We're going to isolate the radical on one side of the equation, meaning I want my square root, cube root, whatever on one side, square root equals or equals square root. Then we are going to use whatever our index is. So if it was a square root, we would square both sides. If it was a cube root, we would cube both sides. Then we're going to solve all the way down until we get an x equals. If it's I was going to say there may be times when we get to x equals. When we square this, wind up with an x squared over here, means we're going to have two solutions. If we get an x cubed over here, we'll wind up with three solutions. So watch out for what's over here. If this has a variable with an exponent, we're going to have more than one solution. So we're just going to hop right into it. So this is example number 1. These are going to be what the problems look like right here. They give us solve square root of 3x minus 5 plus 2 equals 6. And we're going to want to get all the way down to x equals. Whenever they say solve, it means gets us down to an x equals. Y'all, we got a test on Friday. We should probably put the cell phones away. Just saying. There's a test this Friday. So what we're going to do, those steps that they gave us, we have to, first things first, isolate the square root. Isolate. Means I want the square root all by itself. On this line, what do I need to do to get the square root all by itself? Subtract 2. I'm going to minus 2 from both sides. That's a 2. That's still a, that's supposed to be a 2. Minus 2 from both sides. That gives us our square root on the left. And what's on the right? 4. 6 minus 2 gives us 4. Then we're going to deal with our index, is the way I think about it. That's meant to be an E. So since this is a square root right here, how do we undo a square root? What is the opposite of square rooting? Not square rooting again, but like just squaring, right? The opposite of a square root is to square something. I unsquare root it by squaring it. Just like I unsquare something by square rooting. They're inverse operations, if we use that word in a hot minute. So to make the square root go away, I'm going to square the left side. But whatever I do to the left side, I have to do to the right side. So I'm going to square the right side. This causes my square root and my square to cancel out. So we're left with just our 3x minus 5. What is 4 squared? 10? Nope, that's square root of 4. What is 4 squared? Other direction. 16. 4 times 4. I just said 4 too many times, so I didn't think. There we go. And then on this last line here, the book really teleports. They really, really teleport here. 3x minus 5 equals 16, all the way down to x. We're going to kick this into a couple of steps. What do I do to get x by itself right here? Add 5. Easiest way is to add 5. Plus 5. That's going to give me 3x equals 21. Kyla, are you here? There you go, my dear. I don't know what that one is. I think so. There's no time written on it, so I'd say no. What do I do to get x by itself here? Divide by what? 3. And we get that x equals 7. But before we can say, sweet, we're done, end of first problem, We have to check it. There are gonna be times when the solutions that we get don't work because square roots are that inverse operation and there's almost always some sort of restriction on it. It's only that one arm of the parabola when it turns sideways. So we have to check it. We do that by substituting it into our original equation in order to make sure we get an actual answer. It doesn't matter if it's a pretty answer or not, just it has to be something that the calculator doesn't go, ow. That's it. So we're going to take our 7 and we're going to substitute it in here. We need to make sure it has a real solution, not an imaginary one. So all we do is we take our solution that we got, our x equals 7, and substitute it in for x. 3 times 7 minus 5 plus 2. And we type that sucker into a calculator. What does that equal?
18.
Equals 18. Did it equal 18? It should check. I thought it did. I thought this one checked. Let's see. 21 minus 5, 16 square root of 4 plus 2 should not be 18. What'd you get? 6. Yeah. This one should check because the book actually, for once in their life, gave us something that functioned as our first example. Oh, they didn't actually tell us. But this one does check, so if we plug that in, so I'm not sure where we got 16 from. Can I see what you put in there? Square root. The square root around the 3x minus 7 plus 5. Or 3 times 7 minus 5. Yeah, the square root's a super duper important part. Don't forget that bit. So this does in fact equal 6. So this is a valid solution. I say index, I didn't write up here. Should have had solve. And then always a good idea, check. And this does work. This is valid. If it is not valid, does anyone remember what it's called if the solution isn't actually solution? Oh my gosh, didn't this do so much extra work? It's so extra. It's extraneous. Okay, so if the solution, if this part doesn't work, if the check doesn't work, it's extraneous. Because, oh my gosh, that's so much extra work for a solution that doesn't even work. It's so extra. Questions on this first one? Cool. We're doing another. So here's one with the fraction-y root, or the fraction-y exponent, which is 100% the same exact thing as a root. If you like to see roots better, write it as a root. Totally fine. 100% the same thing. Otherwise, it works the exact same. We're going to treat this part like a root, because it is, and we're going to get it by itself first. So what do I do to get this part by itself? I don't need to divide first, because if I do, that's going to give me yucky fractions. Yeah. Yeah, we need to add 9 first. I highly recommend, this is when you want to do PEMDAS in kind of the backwards order. Start with your adding and subtracting, and then do the multiplying and dividing. It'll make your life easier. I'm not saying you can't do multiplying and dividing first, but in this case, we'd wind up with 4 9ths and 9 fourths and 3 fourths, and that's not fun. I don't want to deal with those kind of fractions. So dealing with your adding and subtracting first gives you the least number of fractions. So when we do that, we get 3 plus 9, which is 12. So over here, I've got this written as, whoa, that is not what I meant. Over here, I've got this written as a root. It's the 100% exact same thing as this original statement. If you like this better for your brain, switch them over. They are genuinely 100% exactly the same thing. So now this matches this line. What are we going to do next to get these two things where the root is isolated? How do I get rid of anything outside the root? What you got, Josh?
How would you distribute the 4?
We cannot distribute a 4 into a root, which is what this means, because we would have to deal with all kinds of weird powery things going into it. We would have to, in fact, cube the 4 before we distributed the 4, and that's just too much extra work. So instead of distributing the 4, what are we going to do with it? Divide. I'll tell you what, that was, I guarantee you, lots of people's first instinct. When we are solving for a variable, try and get stuff away with it. Don't put more onto it. So we're going to divide 4 on both sides. That means that 4 is going to cancel out. That 4 cancels, and we're left with 2x plus 6 to the power of 1/3 equals 3. 12 divided by 4 is 3. This is where it can sometimes be easier to see what we're doing in root form. Because how do I get this out of the root? What do I need to do to it? Not divide it. How do I get rid of the root? What's the opposite of cube rooting? Not square rooting. To the 3rd power. In the fraction-y bits, it's sometimes a little harder to spot. But I need to get rid of this denominator. So we are going to raise everybody to the 3rd power. When we raise it to the 3rd power, it makes the power cancel out, or the root over there. We cube it. Makes the exponents cancel out there. And 3 to the 3rd is 27. It's going to be those powers that kick us in the teeth. When we're undoing a square root, we need to square things. When we're undoing a cube root, we need to cube things. This line. What are we going to do here to get x by itself? Subtract the 6. There we go. Now we're cruising. Minus 6. And we get 2x equals 21. X by itself gives us 21 over 2. Because we got to divide both sides by 2. Plus, they have that answer there for us. Because we're awesome. Then what we need to do, our last step needs to be here. We need to check and see if this works. Take your original expression, the side that has your variables. 4 times 2 times 21 over 2 plus 6 to the 1/3 power minus 9. And type it into a calculator. See what it equals. Just be careful when you're typing stuff in. Make sure you get that exponent as a fraction. Make sure you get your 21 over 2 as a fraction, and that things look exactly like they look up here before we hit enter. Over 3 minus 9. Oop, that is not, there we go. always make sure you type things in right, because I just straight up mistyped a number, and I got the wrong answer. When I fixed everything so it matches exactly on my calculator here, including the 1/3 exponent, it does in fact equal 3, which means this is in fact a valid solution. Substitute it in. Wherever there's an equal sign, type it into the calculator. So even if it had x's on both sides, I would type this side into a calculator and then type this side into a calculator and see if they were the same thing. So I stop at the equal signs to put in my calculator. Questions on this one? What's up, Josh? Oh, raise to an exponent. Push the exponent button. Push the fraction button. There you go. Make sure you know how to do those fraction exponents, because they're gonna be something we can't see. Yes, we do. Yep. Push the right arrow or the down arrow. So you're gonna then push. You already got can't stop in the middle. So from here we're gonna push it out. So we're gonna push this button right here to go up. You're gonna push the fraction button to get a fraction. And then push the down button. You're gonna push the side arrow to go back down. One more time. There you go. Now you can push your right side. Okay, thank you. Practice with these. Do not try and do fraction exponents for the first time on Friday. Because there's going to be times when you just type it into the calculator and give me the value, which I won't be able to walk you through on Friday. So practice these. Okay. Ew, this one's so gross, but that's okay. It's got important pieces. Anyway, so on this one we have to pick our battles because there's square roots on both sides, which is gross. Super gross. And it's not going to come up something that we see super often. But I have square root of x plus 21 and 3 minus the square root of x. So I have one square root all by itself. It is there. So what we're going to do is we're going to start out with getting rid of the square root on the left side. How do I get rid of a square root? Square it. Thank you. So that's going to cancel out with this piece. But then I also have to square this side. So we wind up with x plus 21 on the left side. And then this piece we actually have to multiply out. Like we have to box multiply it, or you have to distribute it out. I'm going to do a box just because I like boxes. And I feel like they're visually very easy to see. So we have 3 minus the square root of x, gross, and 3 minus the square root of x, gross. Three times 3 gives us 9. 3 times negative square root of x, gross, gives us negative 3 square root of x. 3 times the negative square root of x is negative 3 square root of x. And the negative square root of x times the negative square root of x is x. Positive x. Super gross. So we're going to take all the pieces out of the box and line them up. I've got 9 We're going to combine some like terms here. -3 plus -3 gives us -6 combining together. Let's just see that adding and subtracting. Why the heck we had to do that before we could start solving them. And then plus x on the end. All right, so I've gotten rid of one of my square roots. I got rid of 1 from this original expression. Now we're gonna like the whole thing here is to get rid of the square root. So I need to get this square root all by itself. These are not gonna be like the super common ways we do these. We're gonna have to do it twice, but there's an important thing in here we need to see, which is why we're doing this one, even though it makes us go, gross. So I need to get this square root all by itself now. This square root all by itself. Which means I need to move the 9 to the other side of the equal sign. How do I move that 9 to the other side? Subtract the 9. Subtract the 9. Means I also need to get this x to go to the other side. How do I move that x? Subtract it. Minus x. Minus x. So we have 21 minus 9, which is 12. Yeah, 12. And x minus x, which they go away. They cancel out. 1x minus 1x gives me no more x's. All gone. We're getting there. Now, if we started here, that's exactly the stuff we did before. The rest of this is gross. But it's a thing. Now I want to get that square root by itself. We're isolating the square root. What do I do to get the square root by itself? Divide by the -6, which leaves us with what on the left side? -2. -2 is the square root of x. What's up? Because it's not the square root of x plus or minus 6, it's they're smashed together. If the minus was in between, we could talk about it. But since they're smashed together, that means -6 times the square root of x. So watch out for that, because that is a super duper duper common mistake there too. So if the square root of x is -2, what do we do to get rid of the square root? Square it. What's -2 squared? -2 times -2 is? +4. When we're squaring the whole side, if you're doing it in your calculator, put in parentheses. Calculator is not able to read your mind, so it's assuming you mean -2 squared, not -2 squared. The way the calculator reads a negative sign like that is -1 times, and it is doing an order of operations and assuming that the exponent is being done first. Especially when you have negative values. You always put it in parentheses. Because our calculators are only as smart as our thumbs. They struggle with order of operations when it comes to negative numbers. So when in doubt, put it in parentheses. So we get a 4 here. So we need to check it. Check, 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 check. So we take our original expression. I am going to do each of these individually because that lets me check and see what's going on here. So I'm going to take the left side, that's square root of x plus 21. And I'm going to substitute my 4 in. 4 plus 21 gives me 25. What is the square root of 25? 5. Sweet. We're going to do the right side. 3 minus the square root of x. So 3 minus the square root of 4. What is the square root of 4? 2. What is 3 minus 2? 1. 1. Does 5 equal 1? No. No. This does not satisfy the original equation. So it is an extraneous, or so it is a, I don't know what word they want me to put there. This is extraneous. This one. Therefore, there is no solution. Where square root of x plus 21 equals 3 minus the square root of x. There's no place where those two things equal each other. So that is why I call this so extra. It made us do all that work for no solution. It is extraneous because that is so extra. They made us do so much work. Oh my gosh. So extra. So that is why we have to check it, because sometimes it doesn't work. We do all this work and it doesn't work because they're meanies. Questions on this one? Okay. Because that's where we're going to stop today. We will finish it up tomorrow where they go into some kind of wild and crazy different things that can happen when solving these. Sometimes when we might have more than one solution or might have more than one answer, and we have to figure out which one's valid and which one's extraneous. So this is our last air quotes homework of the chapter. We will have a chapter review that we're working on after this. So it's up on the website. Should be. And those are the numbers in the book of what we're doing. Chapter test is Friday. Friday's the test. Test is Friday. We will do notes tomorrow, and then we will review for 2 days, and then it'll be test. Okay? If you want to start early on the chapter review, they're over in the hanging file folder under the spinny pencil above the turn-in bin, second from the bottom file folder. It says A2 review on the little post-it note to the side. There also is going to be an interactive review on Alex. We started with that program originally. Like the very second day of school, we did some stuff in Alex trying to get it up and running because we're going to have chapter reviews there. I'll get it set up today, so if you are one of those people that likes to start reviewing early, it'll be in Alex, ready to go. But this solving stuff, which we've done all the things, it's just going to kick up a notch where we might have 2 solutions tomorrow. But it's the same process. It's the same steps. We just may have an x squared on one side once we get rid of the square root, which means we may have to factor. Yay. All right, but that's all I got for you today. There are 10 minutes until announcement starts. So if you got questions, let me know. Otherwise, rock on.